Now we are performing the experiment to find out the refractive index of a glass slab using traveling microscope. Now the apparatus and the material required in this experiment. So first, that is the traveling microscope, the glass slab, a plain paper and a chalk stick. Now first we have to find the least count of traveling microscope, and for that we have to take value of the one division of main scale as well as the total number of divisions on the vernier scale. The ratio of these two will give you least count. Now when we move traveling microscope in horizontal direction, then we have to use this horizontal scale, and when we move it vertically up or down, at that time we have to use this vertical scale for the measurements. Now this is the main scale and this small one is the vernier scale. We have to find the value of one division of this main scale, and now see carefully here. In 1 centimeter of the main scale, total 20 divisions are there. And see, on the vernier scale, there are total 50 divisions, starting from this arrow to this last one. Okay, total 50 divisions are there. Now in 1 centimeter of the main scale, there are 20 divisions. It implies that value of one division, that is 1 by 20 centimeter, and it is divided by the total division on the vernier scale and are 50. So it is 1 upon 1000. So least count of the traveling microscope comes to 0.001 centimeter. Now make a dot on the white paper with your pen, as you see. Now observe that spot from the microscope. First it seems faded one. Now seeing in the microscope, with the help of this knob, move the microscope up and down and observe the sharp image of that particular spot in the microscope. You have to observe it as sharp as you see in the video. Now take the observation of main scale and then check which division of the vernier scale is perfectly coinciding with any division of the main scale. So here we have to take the observation as you took in the experiment of vernier calipers. Now place glass slab on the spot and observe in the microscope. Your spot will be faded one. Now observe in the microscope and using this particular knob, release it and move your microscope up and observe the sharp image of the spot, and then tight the screw. Again take the observation of main scale here and find out the division of the vernier scale, which one is perfectly coinciding with any division of the main scale. Now sprinkle the chalk dust on the glass slab as you see in the video. Now observe chalk dust through the microscope. Release this screw and move your microscope and observe sharp images of the chalk dust particles, and then fix the knob. Clear image of the dust particles should be observed as you see in the video. Now prepare the observation table as shown here. In our case, when the mark is made on the paper at that time. The main scale reading M is 4.85 and the 19th division of the vernier scale is perfectly coinciding with a division of main scale. So multiply 19 by least count 0.001. So our reading, that is 0.019. And now add this 0.019 into main scale reading, and finally our reading, that is 4.869. Then after the slab placed on the mark and the main scale reading measured 5.4 centimeter and the 11th division of vernier scale was perfectly coinciding with a division of main scale. So multiply 11 by least count, that is 0.001. So we will get 0.011, and now add this one into main scale reading 5.4. So we will get 5.411 centimeter. Then the dust was sprinkled on the glass surface, and again main scale reading observed is 6.6 centimeter and 10th division of the vernier scale was perfectly coinciding with a division of main scale. So multiply it by least count and then add it in the main scale reading, and finally we get 6.610 centimeter. Now refractive index of the glass, that is the ratio of the real thickness of the glass slab to the apparent thickness of the glass slab. So now take the difference A3 minus A1 and A3 minus A2 and solve this ratio as calculated here, and you will get the answer 1.45. Now repeat the experiment for 2 more observations, and for those observations calculate the refractive index, and then after take mean value of the refractive index. Now estimation of error in the observation. So the equation, that is delta n glass with respect to air upon n glass with respect to air, that is delta B upon B plus delta C upon C. So we can calculate delta n as per this equation. Now first of all we have to calculate delta B upon B and delta C upon C. So equations for delta B upon B and delta C upon C are, as you see here, delta B upon B, that is delta A upon A1 plus delta A upon A3. Now here delta A, that is least count of the microscope, which we already measured, and the observations A1 and A3, which also we measured. Then calculate this value delta B by B by substituting the values of delta A, A1, A3. Similarly, calculate delta C by C by substituting the values of delta A and A1, A2. And then after substitute the values of delta B by B and delta C by C in this equation and calculate delta NG. Now for your 3 observations, calculate delta NG 3 times, and then after take the maximum value of delta NG and then represent your final result with that maximum possible error that is your final result. Here NGA, that is your mean value which we calculated previously.